Hi guys, welcome to uh, my live section. Okay, so I have about 20 questions that I want to treat with us, and those questions are common questions in exams like SAT, ACT, GCSE. Okay, so I have about 20 questions. I hope we have enough time to treat these 20 questions. Okay, so I'm going to start with this. You have to factorize root 3 x squared plus 10x plus 8 root 3. Okay, so let's factorize this. This is one of the commonest questions in exams like SATs and the rest. So now let's see how we can do it. All right, so what we are going to do is that we are going to multiply these root 3 and 8 root 3. Okay, so that's going to be our factor. Okay, so let's multiply these three, the coefficient of the square variable and the constant, which is 8 root 3. So we do that first. Sorry, the video is okay. I think it's stable like this. All right, so when we do that, we have root 3 times 8 root 3. Okay, so and that give 8 times root 3 times 3 will give us root 9, and square root of 9 is 3, so we have 3. Then 8 times 3 is 24. Okay, so now we are going to look for factors of 24 that will give us 10 if we add it. All right, so what are the factors of 24? We have 2 times 12 will give us 24. We have 6 times 4. 6 times 4 will also give us 24. Okay, so now I think 6 times 4 will work because 6 times 4 will give us 10 when we add it. 6 times 4 will give us 24 when we multiply. And then when we do 6 plus 4, it will give us 10. So we are going to write root 3 x squared. Now, mind you, the root 3, this root, square root, does not cover x squared. It only covers 3. Okay, so we have plus, now, don't forget we have 6 times 3. That's the factor we want to use. All right, so, and then 6 plus 4 will give us 24. So we have 6x, then plus 4x, then plus 8 root 3. Okay, hope it's clear enough. Hope you guys can hear me clearly, and the video is clear enough. Hope you guys can see it. Okay, so if you can see it, just type yes. So I want to be sure you guys can see it clearly. All right, so now we have 6x plus 4x. 6x plus 4x will give us 10x. And 6 times 4 will give us 24. Now, these two, we have these two. We're going to pair it. These first two, we look for what is common. And then also, these last two, we also look for what is common. Now, if you look at this, the only thing that is common here is x, right? And then these other two last pair, the only thing that is common there is 4. But there is a way we can write this such that we can have other common factor apart from x. Okay, so now let me write it this way. I will say root x is common. Look at what I will do. If I say root 3x, okay, don't forget the roots does not cover 3, x, it can only cover 3. So I will say root 3x, then x plus 6 over root 3. Okay, so by the time you open this bracket, that bracket, you are going to have this, the first pair. Root 3x times x will give us root 3x squared, and then root 3x multiplying 6 over root 3 will give us 6x. Okay, so how does that work? We have root 3x multiplying 6 over root 3. So at the end, I don't know you guys, okay, let me shift it. At the end, this root 3, we cancel this root 3. And then we have x times 6, which will give us 6x. So it means that if you expand, if you open this, we are going to have this. All right, so the second pair, we look for what is common. 4 is common here. The common factor here is 4. So if we have 4, we have x left here. And then in this place, what do we have? We have 2 root 3. That is what we have here. By the time you open these brackets, 4 times x will give us 4x. 4 times this will give us this. All right, so now remember that what you have in these brackets and these other brackets must be the same, okay? But then it's looking like they are not having the same stuffs inside them. This one is having x plus 6 over root 3, while this one is having x plus 2 root 3. Okay, now we can rationalize this. You know, in third, if you have 6 over root 3, this root 3 cannot be your denominator. We are going to rationalize it. So let's rationalize it to have it in this form. Okay, now we have, let me shift this. So we have 6 over root 3. By the time we rationalize it, multiply this by root 3, multiply this by root 3, then 6 times this will give us 6 root 3. Root 3 times root 3 will give us 3, okay, because that will be root 9. And then 3 here 1, 3 here 2. It gives us 2 root 3. So it means that another way we can write this now. Now let me write this again. We have root 3x, x plus this is also 2 root 3. When we rationalize it, we have 2 root 3. All right, so in the first bracket, okay, yes, that is what we have. Michelle, I already wrote it. That is what we have in the first bracket. Then the second bracket, okay, the second pair, we have this. Okay, now that we have the same stuffs in the two brackets, then we can go ahead to pick one. Then you join what we have here and here together, and that is root 3x plus 4. Okay, and then since we have the same bracket, we're going to pick one, and when we pick it, we have x plus 2 root 3. All right, so this has been factorized. This has been factorized. It actually looks, at first it looks impossible. It looks like it's something we can't factorize, but at the end of it all, we are able to factorize this. All right, so in the same process with our normal factorization, just that we're having radicals. That is why it's looking a bit tough. Okay, let's look at another one. No, I told you that we have about 20 questions to treat, and these 20 questions are the most asked questions in exams. Okay, generally exams, SAT, ACT, GCSE, JEE, all right, and other exams. So please, this is the first one. I think I'm going to write number 1. We are going to note 20. Okay, so now let's go on to the second one. All right, so now number 2. This one is also very, very common. Okay, the question says decrease $28.5 by 30%. Okay, I hope this is clear enough. Okay, decrease 28.5 by 30%. Right, so we can either increase it or decrease it. So since we are having decrease, what we are going to do first is to find 30% of 28.5. That is the first thing we are going to do. Then afterwards, we can now, decrease it. Now, 30% solution. 30% of 38, 28.5 without using the calculator. Everything we are doing here, I think we can do this without using the calculator. I'm going to show us how to do that. So 30% of 28.5. And then how do you write 30%? Same thing as 30 over 100. 30 over 100 is 30%. Then off its times 28.5. Another way to write 28.5 is 285 over 10. Okay, because 285 over 10 will give us 28.5. Now, 0 here, cancel this one. And then we're having 3 times 285. All right, 3 times 285. What would that give us? Can somebody do that? What is 28? So we're having 3 times 285 over, then this other one we have 10 times 10. This is 100 already. All right, so let's have what is 3 times 285? Can somebody just tell us what 3 times 285 is? 3 times 285. Okay, anybody that is very fast with calculation. 3 times 285. Okay, 3 times 285. Anybody? I don't know math, sorry. Hey, sorry, Kongel, Craig. You don't know math. Okay, you can, if you stay back, I'm going to explain this in a way that you understand. Just stay back and just follow up. We have about 20 questions and we are just in number 2. All right, pressures. You said 855, okay. 855, are you sure? 3 times, is it 855? Okay, if it's 855, do anybody have another answer to that? 3 times 285. Is it 855? Okay, so 855. 855. Okay, so that is 855 over 100. So when you divide this by 100, we have, okay, you said 8.55. Yes, exactly. So this divided by 100, we shift it twice, 1, 2, and that is 8.55. All right, so now 30% of $28.5 is $8.55. Okay, now we have to decrease. When you have to decrease, it means you're going to subtract this from the 28.5. Don't forget we are decreasing. We want to decrease. Decrease means to remove, to subtract. And then we do the 28.5 minus 8.55. Okay, so 28.5 can also be written as 28.50. So what do we have? If you subtract 8.55 from 28.50, so what's the final answer? 28.5 minus 8.55, what will be the final answer? Okay. So what do we have as final answer? 28.5 minus 8.55. Okay, we are waiting. What do we have? 28.5. Who is giving us the answer? 28.5 minus 8.55. Okay, 20. That should be more than, it should be less than 20. It is 28.50 minus 8.55. It can't be exactly 20. I think it should be around 19.95 or thereabout. Yes. We are not approximating it. We just want the right answer. All right, I think this should give us 19.95. Yes, should give us 19.95. Okay, so now if you decrease, the question says you decrease $28.5 by 30%. That has been decreased, and what we have is 19.95. 19.95, that's the final answer. Okay, so that's number 2. Let's move on to number 3. Okay, I told us we have 20 questions, 20 common questions. So let's go to number 3. Number 3 is going to be another topic entirely. If you are just joining this live class, please don't forget to like, share it, like the live, share it, and if you have not subscribed to this channel, please. Now let's go to the next one. The next one, which is number 3. Number 3 now. We are in number 3 question. Okay, so the number 3 question is a radical equation, and it is also very common in exams. Yes, it's very, very common in exams. Okay, so let's say we have something like root x plus 5 equals to root 4x. Okay, so this is what we have. And the question is, you should find x. You have to find x. Now, this is what we do. We can bring those terms with x together. But before we do that, we can find square root of 4. So let's write it as root x plus 5 equals to, we can give these separate square roots. Square root 4, then we have square root x. Okay, so we have root x plus 5. Square root of 4 is 2. And then 2 times root x will give us 2 root x. All right, so now we have root x and 2 root x. They are like terms. Let's bring them together. By the time we bring them together, we can take this to the other side. So we have 5 here. Then we have these 2 root x. Let's move this root x. If you move it to this side, it becomes this. And then, now, 2 root x minus x. We can factor out the root x. Okay, here now, root x is common. We can factor it out. So we have 5 equals to, root x is common, it's out. What do we have here? We have 2 minus, what do we have? We have 1. Okay, so this is one way of doing it. Because by the time we open this bracket, root x times 2 will give us 2 root x. Then root x times minus 1 will give us minus root x. You can see. All right, so now we have 2 minus 1 is 1. Okay, so we have this to be 1. And then root x times 1 will give us root x. So we have 5 equals to root x, or we say root x equals to 5 is the same thing. Okay, and then what do we do from here? We are going to find, take the square of both sides. All right, so why do we need to take the square of both sides? Because we want to cancel out the square. We have to take square of both sides. So we take square of this side, we take square of this side, and we also take square of this side. And then the square, we cancel the square roots. Okay, that's the reason why we have taken the square of both sides. Then 5 square means 5 times 5. 5 square means 5 times 5, which is 25. So it means that x is equal to 25. Okay, I've said before, it's a radical equation and it is always asked in exams. So this is number 3. This is question number 3. Now let's look at another question, and then it's going to be another topic, and it is also one of the most asked questions in exams. Okay, so let's look at another one, and that is number 4. Okay, so the next one is number 4. Let's see what we have. Number 4. Okay, so please don't forget to share this live. We have 20 questions that we want to treat. Okay. Uh, all right, so we have absolute value equation, and the question says you solve 2x minus 5 equals to 9. Okay, so this is an absolute value equation. You are asked to find x, and this is also one of the most asked questions in exams. Now, solution, let's look at it. If you apply this absolute value equation, it says that if we have A equals to B, okay, and then what that means is that A is equals to B, or A is equals to minus B. Okay, so that is what we are applying. It says that A equals to B, or A is equals to minus B. So we are going to have two equations. The first one will be 2x minus 5 equals to 9. And the second one is going to be 2x minus 5 equals to minus 9. Okay, so what it means is that you see this A is represented by 2x minus 5. That is what the A is. And the B is 9. Okay, and then it means that we have A equals to B. You're going to take this equals to this. Or the second answer will be A equals to minus B, that this equals to minus this. Now, let me show you what I'm talking about. The first one is going to be this A minus A equals to B, will be 2x minus 5 equals to 9, okay? Or we have 2x minus 5 equals to minus 9. Okay, so we are solving two equations simultaneously. Okay, so now from this first one, you take this minus 5 to the other side. Okay, I'm treating the first one, which is 2x minus 5 equals to 9. All right, so I will take this to that side. We have 2x equals to 9 plus 5. And then that means 2x is equals to 14. So if 2x equals to 14, what is our x? Our x now will be 14 over 2. So x now will be 14 over 2, and that gives our x to be 7. So x equals to 7. This is one of the solutions. Then don't forget, I said that or this, so let's look at this now. A equals to minus B. Okay, don't forget our equation. 2x minus 5 equals to minus 9 now. Okay, so we have 2x minus 5 equals to minus 9. We take this minus 5 to that side, so we have 2x equals to minus 9 plus 5. Okay, and then minus 9 plus 5 will give us minus 4, right? So we have minus 4. Then how do we find x? X now equals to minus 4 over 2, and finally x equals to minus 2. So we have two answers. We have x equals to 7, or x equals to minus 2. So those are the two answer solutions we have if we solve this absolute value equation. All right, so that is our fourth question. I think we should move a bit faster so that we'll be able to cover the whole 20 questions. And if you're unable to cover the 20, I think we should be able to do 10. Yes, then some other time we continue from there. But trust me, these questions we are treating are common questions in exams. are common questions in exams. Okay, probably at the end of it all, I'm going to give us some to do. Now, let's look at number 5. Another one, number 5. Our fifth question now, number 5. Question 5. All right, so let's look at logarithm. We have logarithm, but this logarithm is a bit logical. We have log 16 base x equals to